The first one in order of operations is special operations. PEMDAS and BEDMAS only have parentheses and exponents. Parentheses, brackets, exponents. What about factorials? What about radicals? What about larger nth root factorials? I mean, radicals. What about derivatives? What about integrals, double integrals, linears? When you get to calculus and higher ones, there are over 400 operations in mathematics. PEMDAS only deals with 2 of them, so it's very limiting. So do any special operations first. Anything that looks funny, do that first. Multiplication and division are on the same level. One is not more important than the other. They're the same level of importance. Addition, subtraction. Yeah, I would take a little bit of notes also. Mathematics is a language. When you read something, how do you read it? Left to right. Mathematics is a language also. So how do you read math? Read it from left to right. And just like a computer, every time you do something, write down what you just have, what you have left, and repeat the same logic. Are there any special operations? Are there any multiplication divisions? Are there any addition subtractions? Do whatever you have to do, then rewrite, start again. Keep on going and going and going, and everything's going to wash out towards the end. So again, it's very important that we go left to right. In our example here, if we went left to right, what do we get to first? Multiplication and division are the same level of importance. So we have to do division first, and then multiplication. We have to do multiplication first, then division. But if the operations are all the same, does it matter? Not for multiplication, but look what happens to division. Let's look at what division really means. 6 or 12 divided by 6 divided by 2. What that means is 12 divided by 6, whatever that is divided by 2. So we have to do this first, and then we do the final division. So whenever we rewrite it from the symbol itself to the operation, then we see it means a lot more than that. So in this class, whenever we have any equations, we use the order of operations. So let's look at some examples of what that means. Whenever you have an equation, the first thing you want to do is start with, are there any special operations? Are there any weird looking equations there? Symbols? No. So what's step 2? Are there any multiplication divisions? Yes. Here's a multiplication right here. So we write down what we have. 5 times 2 is 10. We just did that. Repeat the process. Are there any special operations? No. Are there any multiplication divisions? No. So all we have left is addition, subtraction, left to right. 3 plus 5 is 8. 8 minus 6 is 2. 2 plus 4. This is now where we get the next problem. This is 6 minus 10. 6 minus 10 equals what? 4? Why is it negative 4? It's either 4 or negative 4. What number is bigger, 6 or 10? 10 is bigger. What's the sign of 10? So that means the answer is going to be negative. So whenever you have operations, do the signs and the numbers differently. Because I told you last time, this little negative sign is going to ruin your day. It's going to disappear. It's just going to pop up somewhere. So be very, very careful about that negative sign. Okay, let's try something with a bunch of fractions and numbers. Three over 4 plus 2 over 3 minus 6. Are they all fractions? The answer is every number. The number 2 is the same thing as 2 over 1. So every number is what's called a rational number, a fraction. If there's nothing underneath it, it's automatically a 1. So there's no special operations. Here's division. Yes. Okay, now the rule of thumb is this. Whenever you have fractions in the question, your answers have to be fractions. Not have to, but should be fractions. Always put your answers in the way the question was given to you. So looking at this one, how do we add fractions? Okay. Find a common denominator. See, that's a lot of extra work, isn't it? So let's look at this. Remember I told you that calculators I never used, never liked? You don't need them here. How many of you ever heard of the butterfly method? Just draw a butterfly and then diagonals. 4 times 2 is what? 8. 3 times 3 is 9. And whatever sign there goes there. So on the top, we have 9 plus 8 is 17. On the bottom, multiply 4 times 3 is 12. And that's all there is for adding and subtracting fractions. Make 2 diagonal circles, multiply the numbers inside there, and whatever this sign is, That's the top number. The bottom number is multiply the two denominators. So this number is 17 over 12 minus 6 over 1. Can we use the butterfly method again? Yeah. Butterfly methods only work for addition and subtraction. Seventeen times 1 is 17. Whatever that sign is goes in the middle. 12 times 6 is 72. So the top number is 17 minus 72. What goes on the bottom? 12 times 1 is 12. 12. Is the answer going to be positive or negative? Why? You're right. Because on the top, the bigger number is negative, so the answer is going to be negative up there. So negative 72 minus 17, 72 minus 17 equals 12 minus 7 is 5. 6 minus 1 is 5. So negative 55 over 12. Yes, again, you can always check this now with a calculator. But if you use a calculator, what answer will the calculator give you? Decimal. Is that a decimal? No, it's a fraction. You have to be able to convert both ways. And then we'll talk about this further later on. That's called an improper fraction. How many times does 12 go into 55? 12, 24, 36, 48. So it goes in there 4 times. So 55 minus 48 whatever the difference is goes on top. Yeah, we're going to go through a bunch of these as we go into the course. I'm just giving you a heads up to show you how it's really done. Okay. Ooh, here's another. All right. 3 divided by 5 times 10 divided by 12 times 4 divided by 15 times 20 divided by 21 times 14 divided by 15. Looks ugly, doesn't it? How were you all taught to multiply fractions? Huh? So what would you do first here? You guys would do something first besides get your calculator out. What would you do first? How many of y'all will just multiply all the top numbers together, then all the numbers on the bottom, and then cancel? Who would do that first? Or is this a good quiz question? So let me show you how it's done. Yeah, the way you were probably taught was multiply across top and bottom and then cancel. That's ridiculous because it's going to be a big number, isn't it? 3 times 10 is 30, times 4 is 120, 120 times 2 is 1240, times 14. It's like it's really big. So here's the rule. Always reduce first. Always reduce first. Anything on top, since all of these are multiplied together, anything on top can cancel with anything on the bottom. Anything on top can cancel with anything on the bottom. So reduce first, then multiply numerator times numerator divided by denominator times denominator. Because if you do it this way, it will be in this most simple form possible. Instead of multiplying and then reducing, reduce first and then multiply. It's a lot easier. Let's see. 3. Can this 3 on top, since these are all multiplied, it's actually one big dividing line. Can that 3 cancel with anything on the bottom? Does 3 go into 12? Yeah, 3 goes into 3 once. 3 goes into 12 how many times? 4. No, here we have a 4 here. Can that 4 and that 4 cancel out? That 4 cancels and that 4 cancels. Yeah. What else do we have? Here's a 5. Can it cancel with anything on top? Yeah. 5 goes into 5 once. 5 goes into 10 twice. How about 15? What is 15 made up of? What makes up 15? 5 times 3 is 15. How about 20? What makes up 20? Yeah, 4 times 5 is 20. Can anything cancel now? The 5s. $21 is made up of 3 times 7. 14 is made up of 2 times 7. So we see the 7s can cancel. Can anything else cancel? Let's see what we have on top. We have a 2, a 4, and a 2. Forget the ones. On the bottom, we have a 3 and a 15. Doesn't that equation look a lot easier than the first one? So now, since nothing cancels, we multiply the top by top and bottom by bottom. 2 times 4 is 8, times 2 is 16. 3 times 5 is 45. A lot easier doing it that way. So whenever you have multiplication of fractions, reduce first. Reduce first. Want to try another one? All right, let's try another one. I'm gonna throw a negative in there too now. There. Negative 2 divided by 3. Yes. Oops. Any better? So it's negative 2 over 3 times 5 over 12 times 27 over 30 times negative 1 over 2. So go ahead and work it out and tell me the answer when you finish. First question, is the answer going to be positive or negative? Are you sure? How many negatives do we have in the equation? Negative times negative is a positive. So the answer is going to be positive. Now we don't have to worry about the sign at all. Now all we have to do is worry about the numbers. Well, yeah, it was a negative in the first one and a negative in the last one. They cancel each other out. So can anything on top cancel with anything on the bottom? What can cancel with this 2? How about that? Well, yeah, you could do 12, but you could do 2 goes into 12, 2 goes into 30, 2 goes, so any one of them you can pick. So 2 goes into 2 once, 2 goes into 12 6 times. What else? How about 3? Does 3 go into 5? No. How about 27? 3 goes into 3 once, 3 goes into 27 9 times. What else? How about 5? Does 5 go into 30? 5 goes into 5 once, 5 goes into 30 6 times. Let's see. 6 is made up of 2 times 3. 6 is made up of 2 times 3. 9 is made up of 3 times 3. So can 3 cancel with anything down here? Yeah, the first 3 with that one, and the second 3 with that one. So on the top, we just have 1 times 1 times 1 times 1 times 1, which is 1. 1 times 2 is 2, times 2 is 4, times 2 is 8. So the final answer is positive 1 over 8. So to make things easier, whenever you start breaking things down, like 27. 27 is 3 times 9. 9 is 3 times 3. So 27 breaks down to 3 times 3. This is called prime factorization. Breaking down a number to its smallest pieces. That's the longest part of the whole process. Once you break them down to its smallest pieces, then it's a matter of just eliminating similar numbers. Let's look at these numbers. 10 over 12 times 4 over 15 times 20 over 21. Let's look at those numbers only. Ten is made up of what? Two times 5. You can't go any further. 4 is made up of 2 times 2. Can't go any further with those. 20, 2 times 10. But 10 can go further into 2 times 5. So 20 is 2 times 2 times 5. Break it down. Keep on going until you get nothing else you can do. So on top, we have 2 times 5 times 2 times 2 times 2 times 2 times 5. That's the top numbers. There's a 2 and a 5, 2 and a 2, 2, 2, 5. What is 12 made up of? 2 times 6. Well, 6 can go further. 6 is made up of 2 times 3. So it's 2 times 2 times 3. $15 is made up of 3 times 5. And 21, 3 times 7. That is the hardest part of the whole process, breaking it down. Because for so many years, you've been using calculators to break down your numbers for you. It'll just take practice working your brain to do this stuff. And once you get it back, it'll fly much easier. So now all you have to do is what? Anything that looks the same, get rid of. There's a 5, there's a 5. 3, 3, 3, 7, 2, 2. Nothing else cancels. So I have 2 times 2 is 4, times 2 is 8, times 5 is 40. 3 times 3 is 9, times 3 is 27. So 27 times 7. 7 times 7 is 49. 7 times 2 is 14 plus 4 is 18. So it's 189. Do I have to worry about simplifying any further? No, because I did it all right here. Once I get to this point, the question is, can it go any further? Is gone. So that's what I'm saying is break it down to small pieces. Before you multiply fractions, make them easier, make them smaller. And it makes life much, much simpler for you. So far, so good. I should have started off the semester by, I'm going to teach you nothing. You're going to remember a lot. Because you've seen all this stuff before. How many dozen times? Ever since 4th, 5th grade. It's just that you forgot it since then. So let's go now to the properties of math. This properties tell us when we can do and what we can do when we can do it. So the first property is called the commutative property of colon. The commutative property of. Whenever you see a colon, that means there's a list below there. It could be either commutative property of addition or the commutative property of multiplication. What does to commute mean? Have you ever heard the word commute? What does it mean? To travel, yes. Or more so, move. Yes, it means exactly to travel. You commuted from home to school. You moved from there to here. So what this means is this. With addition, any two numbers you give me, I'll call them X and Y, any numbers. I can put them in any order. I can move them around. Three plus 4 is the same thing as 4 plus 3. 3 plus 4 is 7. 4 plus 3 is 7. So they both equal 7. The same with multiplication. X times Y is the same thing as Y times X. Three times 4 is the same thing as 4 times 3. You notice what I just did there? Multiplication is the only operation that has different signs. I have this, I have a parentheses. So what does that mean? It's 3 times 4. Or I can have the multiplication sign, 4 times 3. They both mean the same thing. 3 times 4 is 12. 4 times 3 is 12. They mean the same thing. So as long as the operations are the same, you can move them around. The second property is the associative property of. Remember, whenever you see the word of, that means there's a list of addition and multiplication. Now, the important thing here, this is where the birth of another one of our math symbols come from. What the associative property says, no matter how many numbers you give me, also X, Y, Z, X, Y, Z. The problem is that there's nothing in our known universe that can calculate any more than 2 numbers at one time. It's impossible. Even the fastest computer has to each take 2 numbers, combine them, and then do the next one. So if I give you 3 numbers, which ones do you put together first? That's where the introduction of the parenthesis comes in. With the associative property, the parenthesis tells us do this first. I just isolated these two to be done first, which is why you hear from the order of operations, always do what first? Inside parentheses. This is why. 3 plus 4 plus 5 equals 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5, 12. Three, 4 plus 5 is 9. 3 plus 9 is 12. It works. So if you're given a series of numbers, if you're given a long series of numbers, you can, you can move them around by the commutative property. You could just put together whatever you want to, and you could tell me which two you're going to put together first. So that allows us freedom of movement in the math equation. Same thing with multiplication. X times Y times Z equals X times Y times Z. Three times 4 times 5 equals 3 times 4 times 5. Do this, go ahead and work this out and tell me which side is easier to do. So on the left side, what do you do first? 3 times 4, which is 12, times 5. On the other side, we do 4 times 5, which is 20. Out of these two, which side's easier to multiply? 12 times 5 or 3 times 20? 3 times 20, because 3 times 2 is 6. Put a 0 behind it. There's no movement of numbers. This one, 5 times 2 is 10. Carry the 1. 5 times 1 is 5 plus 1 is 60. So this is the beauty of the associative property and also commutative property. You can make things, arrange them so it's easier to do. So far, so good. And we'll get to why we're only talking about addition and multiplication in a minute. The third one, which is probably the most important one, is called a distributive property. The distributive property. You notice that there's no of at this one. The other ones we had of, we have multiplication, addition, subtract, separated. This one combines the two. With distributive property, you combine addition and multiplication. A times X plus Y. So what this says is A times whatever's inside here. So the reason it's called distributive because now I take this and I multiply it to each term separately. So A times X is AX plus A times Y is AY. So the beauty of the distributive property is it removes parentheses. because you can't solve an equation if there are parentheses in there. You have to get rid of all that stuff. This gets rid of it for you. What's the number in front called? What's the name given to this number in front? It doesn't have to be a number. It could be a letter. It could be a symbol. It could be a sign. I give you a clue. COEF. Coefficient. Very good. The number in front, whenever you hear the word coefficient, that simply means the number in front. It doesn't have to be in front of parentheses. The number 3x. 3 is the coefficient. It's the number in front. Now, I told you this is a powerful rule because it does two things for us. If we go this way, we get rid of parentheses. We call that distributivity. But we can also go backwards. What do they both have in common? They both have an A, so we can take out. This is called factoring. So the distributive property, depending on which direction you go, can either take away parentheses or put in parentheses. That's pretty powerful. So far, so good. Now we have the more rudimentary ones coming up, the last couples. The identity property of the identity property, it keeps the number, doesn't change it. So for the first one, we have the addition, identity property of addition. X plus, what do we add to X to keep it X? If it was 5, what do we add to 5 to keep it 5? 5 plus 1 is not 5. Very good. That's the last number that was ever introduced into the algebraic system. It was 0. Imagine the concept of 0, of nothing. How do you prove nothing? When the Arabs invented algebra, they didn't have a reason to have 0. But eventually they figured out, okay, in business, how do you know if you're even? If you're equal, so it has to come up with something, 0. Okay, that's the addition. So 3 plus 0 is 3. How about multiplication? X times what gives me X? 1, very good. So 3 times 1 is 3. The inverse properties of keep the number same. That's the top one. So of addition. So X plus what makes it 0? Very good. Negative x. 3 plus negative 3 equals 0. And we'll see why this is important in a little bit. And the multiplication, x times what gives us 1? You see that? That's what you meant to say. The reciprocal of a number is 1 when you multiply it. So in other words, if I gave you 4 over 3, what times 4 over 3 equals 1? Flip it. 3 over 4. 5 times 1 over 5 equals 1. X over y is the same times 1 y over x. If you flip it, you get the same. Well, how are these the same rules? What's the bottom of 5? Right. Because every number is a fraction and you could flip it. The nullity property. So what makes it equal 0? We actually did the first one already. What do you add to x to get 0? Negative x. Y times what equals 0? What do you multiply to y to get 0? 0. Anything times 0 is 0. Those are the properties. Everything in any level math follow these rules. So this set of rules with the order of operations, once you know those, you could do any level math at all. I can teach you calculus. As soon as you learn all these and memorize these, I can teach you calculus, because all it is a series of steps that you have to follow, which is what we're going to do in this class. Now, let me define a couple of, not really define. What does addition really mean? The process really means this. If the signs are the same, if the signs are the same, then take the common sign and add the numbers. If the signs are the same, take the common sign and just add the numbers. 2 plus 5 is what? 7. Positive 7, right? Why is it positive? Because they're both positive. 5 plus 2, also 7. Because they're both positive. Negative 2 minus 5. Yep. They both have a common sign. They're both negative. Add 5 plus 2 is 7. Negative 5 minus 2. They're both negative, so the answer is what? Negative. 5 plus 2 is 7. Yes, these little negative signs ruined so many days on homework problems and quizzes and tests. But that's pretty much, this is the rule. Let's look at subtraction. If the signs are different, then take the sign of the larger number. If the signs are different, take the sign of the larger number and subtract the smaller number from the larger. If the signs are different, take the sign of the larger and take the bigger number minus the smaller number. Again, separate the two processes. Determine whether it's positive or negative, and then tell me the number, and then put them together. If you do it that way, you'll almost never have the problems of signs again. Five minus 2. Which number is bigger? This one's positive, this one's negative. Which number is bigger? 5. What's its sign? Positive, so the answer is positive. 5 minus 2 is positive 3. Positive 2 minus 5. The signs are different. What's the answer going to be? Is it positive or negative? Since 5 is bigger than 2, it's negative. The answer is negative. Now we take 5 minus 2. So the answer is negative 3. Negative 2 plus 9. 9 is bigger than 2, so the answer is positive. So we subtract the smaller from the larger. The answer is positive 7. Nine is bigger than 2. It's negative. Subtract the smaller from the larger. So the answer is negative 7. What do you think? We covered a lot of stuff there, but you've seen this stuff before. Now, the next half of this class, we have to start. Unfortunately, I wanted us to start doing work, but we can't do work because we haven't learned the concepts yet. Because well, I guess we can. The next one first chapter section deals with graphing. So when we come back from our break, we'll start section 1, chapter 1. If you want to, you take out your computers and we can start doing the homework in class. All right. So let's take like a 15-minute break or 10-minute break, come back. As soon as everybody's back, we'll start. If you have any questions, holler. All right, chapter 1, section 1. Let's look at the first section. Talks about graphing. Well, graphs, introduction of graphs and lines and everything. When we say graph, what do we mean? When we talk about graphs, what are we talking about? It means to plot points, plotting points on a coordinate system. It means to plot points on a coordinate system. We're used to seeing this. Now, where did this come about? Think about your whole education system. When you first started learning numbers, what graph did you first see learning numbers? In the beginning, you had a number line. This is your first introduction to graphs. You had a starting point, call it 0. Anything to the right was positive. Anything to the left of 0 was negative. Well, yeah, that's the same way to think about it, how humans traveled. We walked, we took wagons, took boats, everything's horizontal. And then what happened? And then eventually we started going up and down. Anything going up was positive. Anything going down was negative. Now, the story behind this, the story of this, the system that we use here, was, what is the name of this little chart we always see? Anybody really know the name of it? I gave you the initials. I give you the last one. Coordinate system. It's called the Cartesian coordinate system. It all came about because of a spider. René Descartes, a French mathematician in the 1800s, was lying in bed one day, he was sick, and looking up at his ceiling, well, they had similar to us. We had lines and beams going this way. He saw a spider moving. He says, I can tell exactly where that spider is by how far I go this way and how far away from the wall he goes. That's how come it's named Cartesian, after René Descartes. He invented this by watching a spider move around. He said the corner where his both walls joined, that was what's called the origin. That's where the whole thing starts. Going left and right, that's your horizontal axis. And then going away from him was going up, that was the y coordinate, the y-axis. So now anywhere along this ceiling the spider went, he can tell you exactly where it is. Every location has what's called a coordinate. It defines a point. And it's always, internationally, always this format. The X comes first. Why? Because that's the first one that was developed, the horizontal axis, and then the vertical axis, always. So always move left and right, and then up and down. Starting from the origin. So what's the location of the origin? What's the coordinate of the origin? 0, 0. What's this location? 2, 1. Because starting from the origin, you go horizontally 2 spaces and then up 1. So 2 to the right, 1 up. This one, we go from the origin, we go 4 spaces and then 4 spaces. So this one is at 4, 4. How about that location? Yeah, it's my graphing is horrible. -3, 2. How about that one? Yeah, -4, -2, because we go from here, we go left -4, and then down 2. And this one's going to be horizontal first, so 2, and then down 3. Right. So we have, so we have some examples: 2, 1, -3, 2, -4, -2, 2, -3. Notice the differences in there of each one of the numbers, the sets of numbers. Oh, another name for these are called an ordered pair. Whenever you see the word ordered pair, that simply means the location, the coordinates of a point on a graph. So we see here that we have this cross that's being made, and we have 4 parts. They're called quadrants. Oops, they're called quadrants. There's 4 of them. Quadrants are always written in Roman numerals. 1, 2, 3, 4. What do you notice about the way they have these numbered? Is there an order to them? Well, yeah, it just starts here and goes backwards. How would we do it if we did it today? We'd start where? Probably here and go in circle, clockwise. They did the same thing when they invented this. 700, 800, a couple thousand years ago. What was the only way to tell time? Sundials. So their clock was a sun. Where does the sun start? Where does it rise? In the east. It sets in the west. So the sun starts and it goes, and then it keeps on going until it rises again. That's the reason it was labeled counterclockwise to us, because it followed the motion of the sun and the moon. They needed to define something, so that's what they use. So far, so good? Now, here's the cool part. Given any 2 points, what can we find out? What can we find if we have 2 points? What's that? What's that? The what? Oh, okay, yeah. We could plot the locations, yes. What else? What would the difference find us? Oh, distance, yes, yes, exactly. I'm sorry. The distance between the 2 points. What else can we find? We could find the slope. Why would we find a slope? I mean, it's really, slope means nothing. Yes, because another name for slope is called the rate of change. But you're right. We can find the slope between these 2 points. Can we find the location of the point that's halfway between them? Yeah, that's called a midpoint. We can find the halfway mark. And more importantly, we can find the equation of the line connecting the 2 points. We can find all of this just by giving 2 points. So let's say I give you 2 points. I give you the point 1, 1 and 5, 4. What quadrant are they in? They're both in quadrant 1. Oh, let's get back here. Remember these 4 points we had over here earlier? They relate to quadrants. If they're both positive, they belong to which quadrant? Quadrant 1. In quadrant 1, both numbers are positive. In quadrant 2, what do we have? Negative, positive. Very good. Quadrant 3, they're both negatives. And quadrant 4. Remember, X first, positive, negative. So just by looking at the numbers, you can tell me what quadrant they're in. If they're both negative, we know they're in quadrant 3. If it's to the right and then down, what quadrant does that put us in? 4. If it's to the left and then up, that puts us in quadrant 2. So just by looking at the points, it'll help us define all this stuff. Because now, eventually I'm gonna get to ask you guys that question is, why is this important? When would we ever use this? Think about that. Okay, so let's plot these. That's 1, 2, 4, 5, 6. 2, 3, 4, 5, 6. This is the X. This is the Y. So we had at 1, 1, and at 5, 4. So with that, we can connect the dots. We're eventually going to define the equation of that line. And what can we do with the equation of the line? We can find any other point in existence from infinity to negative infinity. So let's look at, want to do distance first? Let's do slope first. We'll get to distance in a little bit. How would you define slope in words? That is one, yes, that is one possibility, yeah, for movement. But yeah, it's rise over run. How far between the 2 points going up and down over how far left and right they are. Rise is the vertical change, and run is the horizontal change. Or the difference of the y values, the difference of the x values. Mathematically, you'll see it written like this. That little triangle is called delta. Whenever you see the word, the symbol delta, that means change. The triangle. So when we talk about slope, we're talking about the vertical difference versus the horizontal difference. Now, let's put all this stuff together. If I gave you two numbers, 2 and 7, how far is it between those two? 5. How about between 3 and 20? How far is it between those two? What's that? 17, very good. Between 8 and 10, how far is it between there? 2. From 8 to 10 is only 2. Now, how do we get that? How do we know that between 2 and 7 is 5 units? Between 3 and 20 is 17. Between any x I give you, the first one and the second one, how far is it between those two? This means the subscript simply is just a number. It's the first number. This is the second number. That's the first number. That's the second number. So how do we get 5 from 2 and 7? What's that? Very good. So always subtract. So it's the second number minus the first. 7 minus 2 is 5. 20 minus 3 is 17. 10 minus 8 is 2. So the difference between two numbers, x1 and x2, would be x2 minus x1. That's the difference between two numbers. So far, so good. So that's x is a horizontal. How do we do it for the vertical? What would it be for the vertical? We have y1, y2. So what's the difference? Everybody follow along so far? Because this is the derivation. This is where it all comes from. So if you look at this thing, if we drew horizontal, vertical, we have a triangle. How far is it between these two numbers? So it's the second number minus the first number. So that's 4. And between here, the second number minus the first number, which is y2 minus y1. This is x2 minus x1. So what's the slope? The letter we use for slope to make it easier is m. So the slope of this thing, what's the vertical change? 3. So it's 3 over 4. There's the slope. Slopes are always written as fractions, never as decimals. Because looking at this, if I give you this number as a slope, what does it tell me? What it tells me is from this first point, since the top number is positive, what does that tell me to do? It's vertical. So from here, I go up 3. 1, 2, 3. And the bottom number is positive. So it goes to the right. How many spaces? 1, 2, 3, 4. And that gives me to the next point. And I do the same thing, up 3 over 4, up 3 over 4, and I go on for infinitely that many times. So that's what the slope tells me. I go up 3 because it's positive, and I go over 4 to the next point. If it's negative, what does that tell me to do? Yeah, go down and then over to the right. That's what it's telling me to do. So now, if I give you one point and the slope, you can find me the other point by using this map. Up or down, depending on what the top number is, and to the right on the bottom. All right, so let's try that first. Tell me the slope between these 2 points. So remember, our formula for the slope is the difference on the vertical over the difference on the horizontal. So it's m equals y2 minus y1 over x2 over minus x1. Remember, that's what we defined all this stuff earlier. The difference of the y is y2 minus y1. The difference of the x is x2 minus x1. Now, what do these numbers here mean on the bottom? Very good. This tells me this number is the y value of the second point. This tells me it's the y value of the first point. So here's the first point, and here's the second point. So this is x1, y1, x2, y2. It helps if you label these things first before you start. So what is x1? What is x1? X1 is 3. X2 is 5. It's the x value of the second point. The y value of the first point, y1, is 7. Y2 is 60. Once you do that, it's all plug and play. Y2 is 60 minus y1 is 7. X2 is 5. X1 is 3. $60 minus 7 is 53. 5 minus 3 is 2. So there's your slope. From the first point to the second point, you go up 53 points and over 2. There. Of course, we have to throw negatives in there. That's 0.1, that's 0.2. How many of y'all started doing this first? It may sound ridiculous, but trust me, it'll save you. A lot of times I see people do this: X1, X2, Y1, Y2. It's just easier to do it that way, but it's wrong. Always start off by writing your equation. Now you know what to plug and play. Y2 is -7 minus 5. 3 minus a -2. They're both negative, so the top number is going to be negative. Add the numbers. 7 and 5 is 12. Two negatives next to each other. They're multiplying. Negative times negative is a positive. So it's 3 plus 2 is 5. So what can you tell me about this line? What's it going to look like? With your hands, tell me, show me in the air how the line's going to look. Reading left to right, it'll go down. This is a negative slope. Going up is a positive slope. Remember, reading left to right. If it's positive, that means it gets higher. If it's negative, that means it goes lower. So if the slope is negative, that's going to happen. Okay, how about this one? Do both of those. And when you finish finding the slopes, just draw a sketch of what you think it looks like. So 5, 7, 3, 7. And then 5, 7, 5, 3. Do I get those numbers? Now comes the hard part. What does it mean? What is 0 divided by 2? Zero divided by 2 is 0. -4/0 is undefined. Can anybody tell me why those are the cases? How many times does 2 go into 0? Doesn't, does it? So that's 0. How many times does 0 go into 4? It goes in there an infinite number of times. If I promise to give you nothing, how many ways can I do that? Infinite ways. So that's why it's undefined. It doesn't have a number, it doesn't have an end. So if the 0 is on the bottom, it's undefined. So let's look what these graphs look like. If it's 0, here's that 5, 7. And here's that 3, 7. It's a horizontal line. It's a horizontal line. If it's undefined, we have 5, 7, and 5, 3. It's a vertical line. So how can you tell me if you're going to have a horizontal line or a vertical line just looking at the points? What's going to tell me I'm going to have a horizontal line from the points? Yeah. Same y values. And the vertical line? The same x values. Now, why is this important? Because a question could be given to you is this way. I can give you points and you ask you what's the slope. But if you see automatically if the x's are the same, what do you know automatically? If the x's are the same, then it's a vertical line, then the slope's undefined. If the y values are the same, then I know it's going to be 0. It's a horizontal line. Now, the problem comes in memorizing. If I say the slope is 0, what is that going to look like? Without looking at this, tutors. Yes. Here's the easiest way to memorize those kind of things. Now, if it's going this way, from left to right going up, what is that? Positive or negative or 0 or undefined? Positive. If it's going down, it's negative. If it's going up and down, it's what kind of slope? Undefined. If it's going horizontally, 0 slope. It looks childish, but trust me, it'll save you a grade. If it's up and down, it's undefined. If it's horizontally, it's 0. If it's increasing, it's positive. If it's decreasing, it's negative. Every semester, I got students on the final exams, the stuff they turn in. I see this face and they never miss it. People who don't use it, 50-50. Because a lot of times they get these two switched. So far, so good? Okay, we'll do one more thing, then we'll call it a day. So I can tell you guys are all over mathed today. Okay, remember, we'll use the same points. We had at 1, 1, 2, 3, 4, 5, 2, 3, 4. We can draw every 2 points creates a triangle. We knew the difference here was 4, 5 minus 1, and we knew the difference here was 3. So from there, we can determine our slope was 3 over 4, the y over x, rise over run. Now the distance between the 2 points. Here's point A and here's point B. How far are they apart? What kind of picture does this create? A triangle. Do we know any formulas for triangles? The Pythagorean theorem. Do you remember what that is? Very good. A squared plus B squared equals C squared. A, B, C. It says the sum of the square of both sides of a triangle equals the square of the hypotenuse. The hypotenuse is that the hypotenuse is actually the distance. So in our case, what's A? A is the horizontal. So A is x2 minus x1 squared plus, what's B? What's up and down? Y2 minus y1 squared equals C squared. There's the formula. Or we can more so call it the distance, D. But we don't want the square here. How do we get rid of the square? What's opposite of square? Square root, very good. So if we square root both sides, the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. I'll wait to finish. The beautiful thing about this is you don't have to do any work except for the square root and the squares. Have we done this work before? Yeah. The slope. This number is that number. So what do we put in place of x2 minus x1? Yeah, that's x2 minus x1 is 4. Y2 minus y1 is 3. Four squared is 4 times 4 is 16. 3 squared, 3 times 3 is 9. Order of operations, I have to do inside special operations first. So 16 plus 9 is 25. Square root of 25 is 5. So the distance is 5 units away. So yeah, you don't have to plug in all. Once you find the slope, do the calculation for that. Use those numbers. You don't have to plug them in there anymore. Just plug in. This is your x. This is your y. Plug them in there. Here's your x. Here's your y. Or if you want to, you can plug in x2, x1, y2, y1, work it out, which will end up the same way. Okay, so let me ask you to find the distance between these points. Find the distance between those 2 points. So distance between -3, -5, and 2 and 7.